Hello everyone, how are you doing? Welcome to the day 36 and also the module 6, the last module of 40 days of JavaScript. I hope you have enjoyed all the modules, all the sessions that we have done so far. And this module is about going beyond. So let's first take a quick look on what we are going to cover in this module. The module 6 is all about going beyond your advanced level. Yes, we're going to start with JavaScript performance. That's today's video, day 36. After this, we'll be talking about garbage collection. We'll be learning about some of the algorithms that JavaScript applies for garbage collection. Then we'll be talking about JavaScript Web APIs, where I'm going to teach you like with simple code, a small snippet can make wonders in JavaScript. You're going to see that and you can apply in your side hustles, in your projects as well. Then we'll be talking about preparing for JavaScript interviews. I'll be talking through a lot of preparations, what kind of mental state that you should have, whatever we have learned in 40 days of JavaScript, how you can apply them to crack your interview. So stay tuned for day 39. And finally, on day 40, we are going to do a project together. So that's what I'm very excited. Almost coming to an end. Enjoyed a lot. I hope that you did so. So today, let's get started with the first one, day 36, where we're going to talk about performance optimization in JavaScript and the best practices. So what are we going to cover today? So the topics that we'll be covering today will be starting with explaining or understanding what is performance and why performance is important. Then we'll be learning about some of the important techniques. We'll be talking about debouncing, we'll be talking about throttling, we'll be talking about memoizations. Very recently, I have taken a vote on TapasScript channel, and many of you told that you face problem in terms of understanding and applying these concepts. So I'll make sure that after this video, you have a very clear understanding and you will know when and where to apply these concepts. Then we'll talk about what is memory leak. We'll be taking some examples. We'll learn how to fix because that's something that you may be facing in real life while working on the customer application. Then we'll revisit some of the DOM performance issues. We have already spoken in a module elaboratively about DOM and the DOM performance issues, but we'll take a few examples very quickly and talk about them so that it acts as a reminder because you're talking about performance as a whole. Then we'll also talk about over optimization because when you're talking about performance optimization, we also need to keep in mind that we should not over optimize because that's going to kill the performance of the application at the end and will end up as usual with task and assignment. So as you see, there are lots to cover and that's why sometimes the video takes a little bit longer to prepare. I hope you understand. Thank you for all the supporters and the subscribers of TapasScript. You guys are awesome, fantastic. Because of you, I get a lot of motivation to make great content. However, I hope that there will be more people, more developer joining TapasScript, joining 40 days of JavaScript, and you can help. Please share this video, please like, please comment. That will be a great help. All right, so let's get started with the first thing, understanding what is performance and why performance is important. Hey developers, let me ask you this. Do you enjoy sitting in front of those loading indicators or clicking on a button and then keep waiting like what is going to happen next? Or you're scrolling something, you're scrolling it fast, but things are getting very sluggish? Do you enjoy those kind of experience? You don't, right? Most of the cases, what is behind the scene working or not working is related to the performance. Performance is that hidden factor that as a developer we might not get very much concerned when we start developing or creating features, but we should be. And you can do it, you can take care of it pretty well with the understanding of a few techniques that we're going to talk today. So, what is performance? In JavaScript, performance isn't just about the speed or running the application faster. When you talk about performance, you have to think about a few other terms and few other ways that you can accomplish things in your JavaScript. For example, you should understand what is efficiency. You should take care of the resource usage. You should think about responsiveness. You should also think about scalability. So things are kind of related. What does efficiency means? It means that you have developed a feature, but how efficiently that is working in the customer environment. Resource usage. Is it utilizing or using your resource too much so that at the end of the day it is going to cost you a lot because you will be putting your application on some cloud infrastructure or some infrastructure. If the resource usage is high, then it will cost you more. Responsiveness, when someone is interacting with your application, how your application is responding. Is it sluggish? It is coming up fast, or in different kind of devices when they are trying to access it. How is it reacting or how your customers are feeling about it? Then the scalability, when more number of users start using your application, how it is behaving. All these things come together and then define something called performance. So performance, if I have to talk about, it's about writing functions that don't run when they don't need to run. You have to keep that thing in mind as a developer. You have to avoid costly computations. You have to make sure that you are not making the user's device work harder than it should. For example, if it is a mobile devices and if it is working really hard, the battery consumption might be really high, but you can optimize it so that end users devices battery is optimized and is not getting drained because of your application. As a developers, we should take care because we should write code which will take care of all these factors. And as a good developer, that's why some of the techniques like debouncing, throttling, memoizations are very, very important. When I talk about debouncing, I mean that don't act too early. We learn about that. When I talk about throttling, it means that don't act too often. When I'm talking about memoizations, it means that cache the results for the repetitive work and skip the work for the next iteration. We're going to talk about that. So these techniques come together and become so important factor for you as a developer to take care so that your application or your code is performance optimized. If you want to relate it to the real world problems, think about a product page with 1,000 plus items. If you don't optimize the filtering and the rendering of it, your browser is going to melt down, right? After certain interaction, or an input box triggering API calls on every keystroke. It means that you are typing user user on every keystroke. It is making an API call, and the API call could be expensive. Or there are complex animations where you have not thought about, like if users scroll it fast, what is going to happen to the application. Remember, every lag, every freeze of UI, every late response is going to take your end customer or the end users away. If I have to relate performance problem with a real life problem, it is something like in the midnight you are hearing a mosquito near your ear, but you don't really see that mosquito. You are just hearing the mosquitoes roaming around it. That's what your user feels if there is a performance problem in your application. They don't see where exactly the real problem is, but there are a problem that's going to annoy them forever. After all these things, let's get into these important techniques. Let's talk about debouncing, then throttling, and then memoizations. First, what is debouncing? I would define debouncing is a programming technique that we use. The keywords are limit the rate at which a function is executed. That's all. It's a programming technique used to limit the rate at which a function is executed. For example, if you have a text box and you are keep typing with each keystroke, I'm executing a function. I want to control that because that particular function in turns may call an API. Something like this. Here we are seeing a search box, and as and when user types a character on the search box, let's say you want to search and the search happens somewhat at the server side. It means that you have to now call a function, let's say do search, and that function is going to call an API, let's say slash API slash search, which is going to interact with the backend database and then fetch the result, and then the API give the response back to the function, and the function does all required DOM manipulation and then populate the search result. This is a very well-known scenario, isn't it? Now let's imagine that this API call or this function execution is happening on every keystroke. It means that when you type J, you made this function call, does this API call. Same thing happened for A, V, A, S, and it will be on C, R, I, P, T. On every character is going to happen. Isn't that expensive? Isn't that making this API call every character stroke is pretty expensive? Even if this API call is free, because there are certain API execution are priced, you have to pay for it, you have to be a premium customer for that. But even if it is free, think about it, how much load it is going to put on your API server. And if that API server is on the cloud, you have to pay for those executions. So everything is tied together. That's why, guys, the performance is very important. Another factor, forget about all the payment. You're very rich, you can actually take care of all the payment, but how about your users responsiveness? Every time you are putting a character, you're waiting for the response to come. That means on every character stroke you possibly showing some kind of loading over here, or some kind of sluggishness, or some kind of waiting for your user until unless you get the response back for the single character type. This is where debouncing is going to play its role. Debouncing ensures that a function is only executed or called after a certain delay has passed. since the last time it was called. If you remember these two lines, you understand debouncing because now you understand the problem. So, what we are going to do, we are now going to rate limit that particular search function execution. We want to ensure that do search function execution doesn't happen for a particular time period, and it happens only after that certain time period has passed since the last time that function has got executed. Now, what is the time period? It is depending on your application logic. You can give for 500 milliseconds, you can give for 1 second, you can give for 2 seconds, whatever it is. That means since the last time do search function got executed, for the next 500 millisecond, even if user typing, breaking the keyboard, hitting the keyboard, you are not executing the do search function. That's all what debouncing is for. Nothing more than that, nothing less than that. Why and where we use? In the modern web apps where we handle the real-time user interactions like typing, scrolling, resizing your UI, all this control, right? They can flood your application with bunch of events. Every time you type something, it will flood with the keyboard on change event. For example, you scroll so fast, you resize so fast, all events. This all might result into performance issues. One of the issue we have just now seen, where a search input was firing API call on every keystroke. A resize event may recalculate the layouts 100 times per second. You don't want that. A scroll event might update your DOM very frequently. You don't want that. So debouncing will prevent all this overload by waiting until a time period, until a time lapse, and stop this activity that results out of that event. Results out of the event means when you do a keystroke, for the change event, you do a function call. The function calls an API. So the output here is that function call. So we'll stop that function call and that activity for certain period of time. That's what is debouncing. Auto saving is another one. You have an editor where you keep typing. For every keystroke typing, if you want to save the content of that editor somewhere in the DB, is too costly. You want to see when possibly user is taking a pause or after a certain amount of time, whatever is written in the editor you want to save. So this is how you need to think when you are coding, you are building the application, like where you can apply this debouncing technique. Let's understand debouncing with the diagram that you're seeing on your screen. The upper half of the diagram is about without debouncing in picture. It means that here is a timeline, and on this timeline on 0th millisecond, 100 millisecond, 200 millisecond, every 100 millisecond there is an event. E indicates an event. It can be any event, change event, scroll event, any event. Now what happened here, without debouncing, on each event there can be a action. Could be a function call, could be an API call, whatever happens. So for every event on every 100 millisecond, there is an expensive, inefficient function call that's going to happen. And because of that, the impact could be is your performance of the application goes down. This is what is happening without debouncing. Now with debouncing, the major difference over here is the event will happen just like before on every 100 milliseconds, but we can have a timer. For example, let's assume we have a timer for 500 milliseconds. So it means that for 500 milliseconds, even if the event occurs, the output of the event, the function call or the API call will not be made. After 500 milliseconds, the call will happen, the API call will happen, and after that, again, the timer will be resetted for the next 500 milliseconds. This is how it works, okay, guys? First time you are starting with a particular timer value. It could be 500 millisecond, 1 second, 2 second, based on your use case. And after that only the execution of your event triggers will take place, and after that again it is not going to execute anything even when your events are occurring on your application. It will reset the timer again for the next 500 milliseconds or whatever the timer that you have given. You have to remember, now if you're talking about that same search box where every keystroke things happen, right? So this is how the flow will be. Every time an event, let's say a keystroke, is triggered, debounce will clear the existing timer if there is one. For example, 500 milliseconds. A new timer will start for the same duration, 500 milliseconds. If another event happens before the timer expires, the timer reset again. Only when no event happens during this particular delay period, the function is finally called. So it means that Wait for the user to stop typing for 500 milliseconds. If they type again before 500 milliseconds, the timer again start over. Okay, enough of talking. Can we see some debouncing code, like how to implement it? Let's do that. To achieve debouncing, you have to write a debounce function. So here is a function. We named it as debounce, very straightforward. What it takes. We are all talking about a delay. Yeah, it will definitely take a delay. And then it will take the function or the functionality that you want to delay for a particular specified delay duration. So you have to pass a function. So these are the two arguments that a debounce function takes. And after taking that, we have to work with the timer, isn't it? Because you're talking about the delay. So let's initialize a timer, and this will return a new function. Of course, the function can be called with any number of arguments, and you are writing the debounce function as a generic function to be called from anywhere. And this particular function can have any number of arguments. Ultimately, I have to call this function after a certain delay. That's my objective. So when I'll call this function after a certain delay, I have to pass this arguments that the function should originally be called with that argument, right? So that's the reason when I am returning a function from my debounce function, I will use the dynamic arguments. These are the dynamic arguments that I'm going to pass inside this fn eventually. So what this function will do, the function that we return from the debounce, it will first thing that is going to do is clear the timeout. This is what we were talking about, that until unless that delay is expired, before that if user is invoking this functionality or if a debounce happening, is going to clear the timer. That's the first thing that is going to do. And then the timer we have will be initializing with the set timeout, because set timeout, we know what it is. It will execute a function after certain delay. That's what set timeout does. So over here, I can take an arrow function or a normal function. I have this fn. I'll do dot apply. In our session where we explain that this keyword, I have explained what is this call, apply, each of this thing, how to explicitly bind your this keyword. That's why we use, right, the apply. So you can bind the this on the function and then pass all the arguments. And of course, the set timeout is going to take a delay, and that is the delay that we are already passing from the top. And that's about it. This is what is your debounce function is. So see what is happening. A debounce function takes a function that you want to delay, the function execution that you want to delay, and then you pass a delay of your choice. In fact, you can also set this delay value with something very static, for example 100 millisecond. Okay, if no delay is passed, it will make sure that there is at least a 100 millisecond delay. Okay, it's up to you. Then we have a timer, and this debounce function returns another function, because we're going to see that right now, like how we can actually utilize this. What it does, it first clear the timeout, and then it start a new timer with this delay. And after this delay, your function will be called with all the arguments that you will be passing while calling your function using debounce. That's what it does. So here you can see, like for each new input, each new event, if the function gets called, your timer is getting resetted. That is why I told that it works in a way that it waits for the user to stop typing for 500 milliseconds. If they type again before 500 milliseconds, it again starts over. Now let's take a more real life example, and we'll be using the similar debounce function for that. Under day 36, we have a folder called debounce, and here I have created a search.html and a search.js file. Let's look into the search.html file. Quite straightforward. It has got a few styles. I have included the search.js over here. Why differ? You know it by now, because that was covered in the first session of 40 days of JavaScript. And then I have a heading like debounce search, and then an input text box where user can search for it, and then a div below where I'm going to show the search result. And then what is there in the search.js? Let's go ahead and take a look. For that particular text box whose ID is search, I'm now adding an event listener, an input event. You can do a change event. Okay, that also works. And whenever that event occurs, for each keystroke, I am calling a do search method. Do search method is taking what has been typed into the text box, take that query, passing to a function called search array. As the name suggests, this is going to search inside an array, a really bigger array, using this particular query. So if I go to search array now, this is search array where I'm taking the query. I'm putting a console.log or a debug. We can put console.debug also, because it's for debugging purpose. The search executed. Okay, and some kind of time so that I can track it. And then what I'm doing, I am taking the result box, basically search result, where I'm going to put the things after the search result. I'm filtering a big array. This is the data array that you're seeing. I'm creating an array of 10,000 elements dynamically. You can make it 1 million or whatever it is just by increasing it. I'm creating an array of 10,000 elements where each of the element will be a string saying item 0, item 1, item 2, item 3, like that. Then it does the filtering, and then it goes to that result box and populate each of these filtered results. So DOM manipulation also it does. For each of the keystroke, I am going through the array, filtering, taking out the filtered result, going to the DOM, populating. If I type I, it happens. If I type T, it happens. If I type E, it happens. So for typing item 001 or item 100, for all this character stroke, it is going to happen. If I go ahead and see the output, okay, so as and when I type one character in this search box, I'm going to get that console.log over here. Let's try that. First, I, T, E, M. You're seeing that for each of the character stroke, the filtering is happening, and it is also saying the search executed. So this is good. This is working. But the problem is we are doing some heavy computation, searching through the array and also populating the DOM, this heavy computation on each of the keystroke. Now the master stroke will be use debouncing in this context, right? So let's go ahead, modify the code with our debounce function. First, let's bring our debounce function. We know what our debounce function is. We have just now learned. So this is our debounce function, which takes a function, takes a delay, and then clear the timer for each of the event, and then start a new timer where it will execute the same function in the context of all the arguments that will be passing to this particular function. For us, what is this function and what is the delay? Of course, the function is nothing but this do search function, correct? So this do search function is something that we will be putting in debounce, we'll be passing in debounce, and then we'll also pass a delay. Instead of doing this do search here directly, I can now do const debounce search equals to whatever is there from here to here. All these things I can pass inside my debounce function. So I can take this event, query, search query, everything. And of course, debounce function not only take this function that I have to execute after a time delay, I also need to pass a time delay. So let's pass 500 millisecond, half a second as a delay. And then on every keystroke, instead of calling this do search, now I can call this debounce search. And this do search is something that I don't need, so I'll just comment it out. So simple, I have passed my do search, all searching logic to debounce and telling that, hey, don't execute this search array unless this particular time is elapsed. If user is typing something before this time elapsed, again reset the timer. If there is a gap of 500 millisecond since the last time you have executed this function, then only execute it next time. So we are going to see that happening with the same output because our search array is still having this console.log, isn't it? So let's go ahead and open up our search. Okay. All right. So now I'm going to type item very quickly. Okay. ITEM. You see, it didn't execute console.log 4 times. Let's do one more search. Item 111. You saw that? I typed it really fast. Search executed just once. Okay, there is no results because there is nothing called item 111 possibly in my list. But what happened? The search got executed only once. If I just revert back and type the same query again with the same speed, my reverting back will be bringing back this do search. And then instead of debounce search, let's just call this search again. Let's go back and let's type item 111 again with the same speed. You see how many times the search got executed? So that's the difference, guys. With debounce, with the same speed, same number of characters, I had executed the function. If the function is going through the larger array or the API call, it just happened once. But without debouncing, it is happening for every character. It happened 1, 2, 3, 4, 5, 6, 7, 7 times for each of these 7 characters. That's what debouncing is. I hope it is helpful to you. Don't forget to do the task and the assignments that are given around debouncing so that you can learn it really well. Let's move on to the next item, which is throttling. By the way, how is your understanding of debouncing now? Are you liking it? Please post a like to this video. Let me know with a comment below, like if debouncing is fully clear. Let's go to throttling. And here we will also identify what is the difference between debouncing and throttling, because this is one area developers get confused. Like they almost sound similar, what debouncing is doing, what throttling is doing, but they are way different. You have to understand that very clearly. Let's do that. Throttling is another performance optimization technique, but the key point over here is it limits how often a function can be called over time, right? So even if a function is triggered repeatedly by the event, just like before, just like debouncing, same thing. Event triggered is same thing. It's getting triggered. Because of event trigger, there is a function called API call, function called API call. I am only focusing on that function call or the API call. For debouncing, we will not execute that function call or the API call for a certain delay. But for throttling, we will limit how often the number here, okay, number of execution of the function, how often the function can be executed over a time. So if there is a time of 500 millisecond, I am going to decide through throttling how often a function is going to get executed. For debouncing, within 500 millisecond, I am not going to execute the function. I'm going to execute only after 500 millisecond. But for throttling, within the 500 millisecond, I'll decide I am going to execute the function. That's the biggest difference. So unlike debouncing, throttling ensures that the function runs at a regular interval at least once. Okay, so this is how it is. Now, why the throttling will be used and what is the use cases? For debouncing, the use case we understand, right? The user is typing too frequently, and I really don't want to make a function call or API call for a certain duration. So I'm not making that function call or the API call for that particular duration. Very simple. Now, for throttling, also the similar kind of thing. Some events happen very frequently. For example, you're scrolling, you scroll like zoom, you do a mouse movement, tack, 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 tack. You do a window resize, tick, 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 like this, right? These are all very regular activities a user do. Now think about it. Those events are happening very fast. You are resizing your window. For each small resize, there is an event happening. It's not like that. Once you resize from bottom to middle of your screen, then only the event is happening. Event is happening for every small resize. Now for this every small resize event, if you are executing a function that is doing your layout shifting, your layout changes, layout calculation, those are pretty expensive. On top of that, you are doing your DOM updates and all these things are pretty expensive. So throttling will help you ensuring the consistent performance when you're performing such actions, preventing the UI freezing, because if there are too many calculations on your UI for the DOM manipulation, you're doing your resizing, scrolling so fast, your UI might get frozen. And also for the handheld devices like mobile and tablet, it will improve the battery and the memory efficiency. For throttling, what matters is like how many times a particular function will be executed within a time gap. So if you are resizing a window zoom like this and you have stated the handler function of the resize should execute only once in every 400 millisecond, it doesn't matter how fast you are resizing, your that particular function for the DOM manipulation on the resize will execute only once in every 400 milliseconds. That is what is throttling is about. For debouncing, it would have happened only after 400 milliseconds, your function will be called. Here, your function will be called at least once every 400 milliseconds. So instead of calling that function for every nanoseconds, milliseconds on the resize, you are now deciding, oh, I will do the DOM manipulation only after 400 milliseconds of resizing by my user. That's the difference. Let's look into a diagram to understand it even better. Here is a diagram to explain throttling. Let's assume this bar is about the continuous event execution. For example, resize happen, I told right, the scroll happen. So these are the events that are happening, E. Okay. And then there is a throttle interval. In this case, the throttle interval is of 400 milliseconds. So we have given a 400 milliseconds of throttle interval. Now, in each of the throttle interval, though the events keep happening, but we are making sure that the function that gets called because of the event, it happens only once. So in the first throttle interval, it happens here. In the next throttle interval, it happens here. When the next throttle interval happens, for example, 800 to 1200, if the execution will also happen over there. So that's how it happens. So here in the diagram, you can clearly see that we are making sure that the function gets executed at least once within a throttle interval. In case of debouncing, it was always about after a certain interval, then you execute. I hope the differentiation is very clear. Now, as we understand how throttling works, let's implement a functionality. So for throttling, we'll have a function called throttle. And here we are passing the function that we want to execute depending on how many times, at least once in this particular interval. Now, how am I going to achieve that? So for that, I have to keep a track of when was the last time I had executed this particular function. So let's create something called last time and initialize it with 0. Just like debouncing that returned a function, throttle will also return the function because that's the function that will have the actual execution, right? So it will return a function, and this can control the kind of arguments that your actual function takes, and you will keep it as a variable arguments, right? So you'll make it as args. Now here your core logic works. What is the core logic? You first take the time, which is now, is equals to date dot now. Then you can do if, we'll do a difference of time now minus the last time, if this one is greater than or equal to the interval that we have given. This is pure simple logic. Only in this case I will execute the function. So I have the function similar to before. We'll do a apply, do an explicit binding with this, and then pass the args. But this much is not enough, right? We have to again reset this last time. What is the last time will be reset to? Last time will be reset to the time when this execution happens. It means this is reset to now. This much is our throttling logic. Let's go over it once again. So you want to execute a function in an interval, and then again in next interval you want to execute. So you have to remember when the last time the function was executed. And then when you're trying to execute the function, you have to figure it out whether the difference between the last time when the function got executed and the time right now, whether the difference between them is greater than or equals to the interval. For example, you have last time executed the function as 2 5 past 2, and now it is 6 past 2, and your interval is of 2 seconds. So 6 past 2 and 5 past 2, the difference is just 1 second. That means you won't execute this function again because you have to wait for that interval 2 seconds to elapse. That's what we are doing over here, right? We're getting the current time, and then we are doing the last time, now minus last time, taking what is the value. If that value is greater than or equals to the interval we have specified, only in that case we'll execute the function. Otherwise we are not going to execute the function. And you have to also make sure that we are updating the last time with the current time, so that next time when it gets executed, the last time will be the time when it was last executed. Okay, so this is how it is, the throttle function. Now as we understand the throttle function, can we take an example like before we have done the search, right? Can you take another example where we can apply the throttling? Let's do that. Let's understand throttling with the scrolling app. So I have this scroll.html, simple HTML, which is having just one div with an ID called tracker, and it shows the scroll Y position. That's it. We are going to update this scroll Y, this DOM, using the actual scroll Y position by taking this div into a JavaScript using this ID. Let's go to scroll.js, which I have loaded already inside scroll.html. Here on the scroll.js, on window, we have attached a scroll event, and on scroll, we are calling a function called handle scroll. What handle scroll is doing? It is just getting the Y position of the scroll, and I told like I'll be taking that particular div by its ID I'm taking, and its text content, I am putting this value. So if I scroll little down with the scroll Y value, I'll be populating this particular div. And for each movement, basically, for each execution of this handle scroll, I am doing a scroll event fired at, logging it into the console.log so that I can understand what is happening. Now, if I scroll very fast, I am doing a very minimalistic DOM manipulation over here. It is just updating the content of a div. Think about it like you are rearranging things in your UI, or you are populating certain list, lot of values, all this thing on the scroll. This particular operation that handle scroll is doing right now will be much heavier. But with this limited set of DOM manipulation itself, we can see the difference between without throttling and with throttling. So here, no throttling applied now. It is simple scrolling. Let's see the UI once and see the output. Okay, now I'm going to scroll kind of fussy. Every scroll, it is going to give you a console.log. At the right side, it is actually updating. It is also updating the scroll Y. It updated 328 times over here. Okay, it has also updated 328 times every time I scroll down. If I go scroll up, same thing is going to happen. You can see this number is increasing. Both the side is going to update that many times for each of the scroll event happens. Now this is a perfect place where you can apply throttling and can say that, hey, for 400 millisecond, even if you are scrolling, execute that handler function only once. Again on the next 400 millisecond, you execute only once. Now you will see the number of execution that I have done only when I came till this halfway, like 300 and odd, is going to minimize a lot, right? Because now I'm going to make it time bound, and also the number of execution I'm going to control. So I'll go to the same code again. Here, first I'm going to bring back our throttle function, the one that we have just learned and how it works, exactly the same function. The throttle function I have got, and this scroll, handle scroll, now I can wrap it using the throttle. How? I can call the throttle function, where I can pass which function I want to put inside the throttle, which function execution I want to control. That is my handle scroll function. And I'm saying that in this duration, in 300 millisecond duration, I can even make it 400, 500, whatever it is. In this duration, execute this handle scroll function only once. So trigger at most every 400 millisecond. And instead of executing the handle scroll on the scroll event, now I'll be executing the throttle scroll. So I'll be putting this much only the code changes. So the function like debounce, throttle are kind of utility function. You will write it once and you'll be using it multiple places wherever you need. So I have written it once, and then I just wrapped it in a way that I'm passing my actual function that I want to execute on scroll and giving the time limit. Within this time, I want to do it like trigger it at most every that 400 millisecond, and then the throttle scroll is what I'm passing over here. Now you see the improvement in the output. Okay, scroll is 0. Now I'm scrolling again. You see, till this far I came, it was 300, 400 times. Now it is only 9 times, right? It only 9 times. If I go up even fast, it happened only 2 more times. I come down very fast, it happened 4 more times. Now you're seeing that execution, the DOM manipulations, all these things you have reduced humongously just by controlling how many times you want to execute the DOM manipulation function. That's what throttling, my friend. It is really not a rocket science. It's very, very easy. And you also understand the clear differences between a debouncing and the throttling. Again, my request would be you go to the task and assignment and solve it, because I'm putting a lot of effort in teaching you. I want something in return. The first return that you can give me, promise that you will be doing this task and assignments. I'll be feeling really fulfilled. If you do that, come to our Discord, submit your task and assignments. And second thing is like, please support the channel, because it takes a lot to bring the quality content to you. Share about it, talk about it to your friends, comment on it, like on it, so that people reach out to this kind of video again and again. All right, so let's go to the memoizations, which is our next performance optimization technique. Let's get started with the memoization technique. Okay, this is not a spelling mistake. Neither I am mispronouncing it. It is memoization. It is not memorization. Okay. So what is memoization? Memoization is an optimization technique, again, performance optimization technique, where the main focus is on caching. So what you do, you cache the result of an expensive operation and return the cached result when the same input is given in the future. It means for some input, you have done some heavy computation, and then you will cache the result of that heavy computation for that particular input, so that next time, if you give the same input, you won't do the computation again. You will be returning from your cached result. So it's about, you have solved it once, don't solve it again, just give the answer back. So why memoization is helpful? You will be caching the result of a heavy expensive calculation of the operation, like you are doing a factorial, or you are computing the Fibonacci series, or you are doing any kind of matrix operation. These are heavy calculations. You are doing heavy DOM manipulations, you are making heavy API calls. In all this expensive operation scenario, you have to figure out, oh, this is the time for this input, I am going to make this expensive operation. So let me cache the result of that expensive operation for this input. So for this input, I'll be caching the output of an expensive operation. That means I am talking about something like an input to an expensive operation, its output mapping, isn't it? So I have to somewhat map this input with this particular function's output. I have to map it somewhere and I have to keep it. That particular map where I'll be keeping this input versus the expensive operations output is known as cache. Okay. So this will help us in faster execution. It will reduce the CPU usages, smarter resource handling, because these are the things that we were talking about in the beginning, right? What exactly performance optimization means. We can take care of it using this technique. Where and all we can use it? Some of the use cases. The first use case I told about expensive computations like Fibonacci series, factorial, matrix operation, etc. Then for formatting the output, for example, formatting date, formatting complex string. On those cases, when UI re-renders, people are from React world, you know what re-rendering means. So you can prevent the calculation for doing the re-render again and again for the same input. You actually have certain hooks like use memo, use callback in React, right, for the similar purpose. Then for data transformation, you have huge data. From there you are doing sorting, filtering, data aggregation for the same input. If you want to do the same filtering operation again and again on your UI, you are really doing the things unnecessarily. Rather, you can cache the result of a filtered array for the same input, of a sorted array for the same input, or that aggregation function on an array for the same input on a large data set, so that you don't have to compute that again and again and again. Even, in fact, you can also do API caching at the application level, right? So that you can avoid the refetching of identical response, right, for the same input. Next.js, if you have worked with it, there is a phenomena of caching your fetch request, right? That's what we also do with the memoizations. Great. So you know that why memoization exists and why you need to take care of it. Now, can we look into some code of memoization? How are you going to write a basic memoization function? Of course, I'm going to write a basic memoization function. You can improvise on top of it heavy way. And then we'll be seeing the application of that memoization function on an application like we have seen with the scrolling and searching before for throttling and the debouncing, right? So a basic memoization function, how can we write? We'll start with a function named memoize, and we are going to memoize a particular function execution. So we have to pass the function whose execution we want to memoize. This is the function. We have seen the cache seems to be a mapping between an input and the output that caused because of that input after making a heavy computation, right? So now we need a map kind of thing for holding this cache for memoization. We can take simple JavaScript object, we can use that as a map. We can use the map itself. We have learned about the collection called map and set, right, earlier in 40 days of JavaScript. We can also use the map collection, JavaScript map collection itself, for constructing cache. Let's keep it simple. Let's create a cache using the simple object. Here we can maintain the map using the key and value pair. Just like your debouncing, just like your throttling, memoization is also going to return the function through which you can control the dynamic arguments just like before. Now what we need to check? We need to check whether an entry for an input is already there in the cache or not. If it is there, please take out from the cache and return. If it is not there, then only you execute the function, take the output, put it into the cache and return. The flowchart works in this way. If you find the entry in your cache, great, you return. That we call as cache hit. Okay, the term is called cache hit. In case you don't find it in the cache, you have to put the item in the cache so that next time you find it and then return the result. This is called cache miss. Cache hit versus cache miss. These two phenomena is what we're going to code. Let us first take keys. So you'll say JSON dot stringify args that we are passing basically. Now we can check if key in cache, if it is found, then we can say console dot log off. This is a cache hit, right? Because we found things in the cache. And then we are going to return cache for this particular key, because if I pass a key to an object, it is going to return me a value. And this is where we expect a cache to be an object where it has a key and value pair. Key is the input and the value is the computed output for that, right? So we return the computed output. If it doesn't found in the cache, in that case, what are we going to do? If we don't find it, we cannot call it as cache hit, right? We call it as cache miss. And then first thing we'll do is to get the result. Result is with the execution of the function, the function that we are passing in the memoize function. So this particular function dot apply. Now whatever the result of this particular function execution for this input that we have passed, this result now I have to cache. How am I going to cache this result? I'll be caching it as cache for the key and the value will be the result. Okay, and finally I'll be returning the result. That's it. Let's go over it once again. I have a memoize function which can take a function that will be executing, whose output I need to cache. Now this function will be executed for an input. I have to hold the input versus computed output in a map. For that, I have created a cache object. That's what is going to be my cache. So that the key can be the input and the value could be the computed output for that input. Now, this is a function that I'll be returning from the memoize function so that I can take bunch of arguments or the inputs for this particular function that will be executing over here. But before I do anything, first I check this input. For this input, do I have entry in the cache or not? If I have the entry in the cache, it means I have hit the cache. It's great, it's there in the cache. I don't do this computation at all. Rather, I return from the cache directly. So fast. But if I don't find it, unfortunately, then it's a cache miss. In that case, I have to execute the function with this input, and then I will get the result. I'll cache the result so that I next time if the same input pass, now the result is in the cache already, I can return it from here directly, and then I finally return the result. Very simple JavaScript function to take care of it. Can we take a quick example of it? For let's say I have a function called slow square, though it is not a slow function but just mimicking it. Like it, what it does, if you pass a number, it will just do a square and return it. If you pass 2, it will return 2 into 2, 4. If you pass 5, it will return 5 into 5, 25. Okay, but imagine it's a slow computed function. It's slowly computed function. Just imagine. Now this function, if I put through the memoize, what will happen? First time, if I do memoize square of 5, this 5 go inside it. So now args is 5. Now for the key 5, first time the cache is empty. It won't find it. So it will go over here. It will be a cache miss for number 5. It will execute the function that I have passed, which is the square function, with the argument 5. So square of 5 is 25. Result will be 25. In cache, the entry will be for 5, the output is 25. That's the entry. Next time, if I again call the memoized function with the same square function, but with the 5 argument, here the key will be 5. It is trying to find out whether there is an entry for the number 5, any output entry or not. Yes, just before this execution, we have done it. We have kept an entry for 5. So it will find it over here, and it won't go for the computation at all. Rather, it will return it directly from here. So if we see over here, for the first one, it will be a cache miss. For next one, it will be a cache hit. It doesn't have to compute it again. For 6 was never computed before. So again, it will compute and it will be a cache miss. For 5, we have already computed before. So it is cached. So it will be cache hit. Okay. I hope you're understanding the sequence. Now let's take one more realistic example, like how we have done for debouncing and throttling. Let's do it for memoization also and see the output, how it works. Here is an application for calculating the Fibonacci series. You know what is Fibonacci series? You give a number and it calculates the Fibonacci series. If you pass a number and then it create a sequence of like 0, 1, 1, 2, it comes from this, right? 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, and so on. Like that's what the Fibonacci series is. Now, if you pass the number 3, then it will create a Fibonacci series of the number 3. If you pass 10, it will create the Fibonacci series of the number 10 in this particular sequence. If you say Fibonacci series of 32, it will create for 32, right? It will create this particular sequence. Now, what we have done in our HTML, we created 2 buttons and a text field. In the text field, you can enter on which number you want to create the Fibonacci series, 1, 2, 3, 4, etc. As it is a recursive method, if the number is bigger, it is really going to take a lot of time. You are seeing that the fib function is actually calling the fib again. So it's a recursion. In the function course we have seen, that session we have seen what is recursion means. So it is recursively calling. So if you give this number really big, it will call it that much recursively. So the computation is really huge based on the number input. So what is now logical is to cache the output of this particular function execution against the input. So for example, if I give 1, what is the output of this function is remain same every time I pass the argument 1. It will remain same for every time the argument 32. If I pass 32, what will be the output of this fib? It will be always same as long as I pass 32. So for an input, it is always going to return me the same output. Sounds like a pure function, isn't it? So I can now cache the result of the input and the computed value so that next time whenever I'm passing the same input, I don't have to go through this computation again. I can just return the computed value. That's the whole reason these 2 buttons are kept here, to calculate a normal Fibonacci series calculation and to calculate a memoized version of Fibonacci series calculation based on the number I'm putting into this input. And after the calculation, the output will be shown over here. Okay, simple UI. Now, if I go to the run normal and run memo, so this is run normal. What it does is basically it takes the number that you have put into that number box and it calls your fib method, the recursive method for creating the Fibonacci, get the result out of it and write it into the output. And the run memo is actually running the memoized version of the Fibonacci series function. Rest of the code is exactly same. So fib memo, what it is doing, see here, it has created a cache and then it is checking whether the input is already there in the cache or not. If it is there, then return the output straight away. If the input is not there, then in that case, it is computing the Fibonacci series. That is the difference, right? I have showed you one implementation before. This is a implementation, much more shorter implementation, but almost similar implementation of a Fibonacci series with the cache. Now, if I go to the UI, I will see the real result. Let's take a comparatively bigger value. For example, let's say 32. Now, if I calculate normal, what will happen? It calculated the Fibonacci of 32. Number is, of course, after the series become like this, and it taken a time of 16 millisecond. Fair enough. Now, one thing is this 32 and this one is in the cache. The key is 32 and the value is this. This is in the cache. Now, if I calculate the memoize, what will happen? It is not going to compute again for the same number. It is going to look into the cache, try to find out, hey, for 32, do I have an entry? Don't calculate, just fetch the entry and put it. So you will see now it takes just 0 millisecond. See how fast it is. So I hope this example made things really clear for you. So we have learned all the techniques like debouncing, throttling, memoization, right? Now let's quickly talk about things like memory leak, what it is, and let's see some example of memory leak and try to identify how to prevent ourselves from those situations. What is memory leak in JavaScript? A memory leak happens when your JavaScript application retains memory that's no longer needed. I think in this 40 days of JavaScript, we have spoken enough about the references, memory, how the memory gets managed, how the garbage collection works for the weak map, weak set, all these things. And in future, in the coming session, also we are going to talk about how our garbage collection algorithm works. But what you need to understand from the memory leak perspective is the JavaScript application retains memory that's no longer needed. Now, if the application retains memory no longer needed, that means we are preventing the garbage collector to clean it up. So garbage collector sees it, okay, this memory is in use, so I can actually take it out. My algorithm is not applying to take this out to clean it up. So the memory will be retained and hold for a longer time and it might increase even. So it will grow unnecessarily, leading into sluggish performance, UI frozen, browser crashes, all this kind of thing. Can we take an example? Under day 36, you will have a memory leak folder. Just open up leak.html and leak.js. In leak.html, I have a button which says open modal and there is a div which is the modal. You can add anything, any other HTML element inside it. Now my objective is whenever somebody clicking on this button, a modal gets opened. Okay, so this is what my objective. For that, I'll go to the leak.js file. Inside leak.js file, I have little bit of code. Now to get that particular button by its ID, add a click handler like click and then call show modal. What is show modal doing? This is just getting that div what is the modal, adding a paragraph into it like this is a modal. Now what is the problem here? Every time the open button gets clicked, not only attaching an event listener, the line number 5 to 7 is also attaching a click to the body. Two things happening. One listener to this button, another to the body itself. But have you noticed I have never removed either of these listeners in the code? This is where you are persisting the memory that is not required. Once the button is clicked, modal is opened. After that, you really don't need this event listener again. Even if the modal is removed, the listener is persisted in the memory. Over the time, the app will become slower, it will be more memory intensive, and that is where the problem will be. So, how to fix it? Now, to fix it, you should make sure that you clean up these listeners. For example, a code like this, you clean up the listener after 5 seconds. Just an example. So, you have a set timeout. After 5 seconds, what you are doing, you are removing the listener. Now, this won't be persisted in the memory at all. You have taken care of it, right? So, this is a very, very common case of memory leak with the event listener. You create it, you create the leak, but you don't take care of how to remove it. Thus the problem exists in your application. Like this, there are several other situations. It could be with a huge array. It could be unnecessary references to your objects. A lot of things can happen. So be careful about your memory leak. Only thing that you need to make sure that you are aware of, this particular factor, retaining the memory that's no longer needed. That is why the precautions about using weak map, weak set, making sure to make the references to null, all these things come into picture as a standard and the best practice when you are coding and developing the application. Otherwise, unknowingly, you will introduce memory leak in your application. There are various ways you can detect memory leak in your application. For example, Chrome DevTools, if you go, here you have a tab called memory. This particular tab is very, very useful for finding out if there is a memory leak or not. There is another tab called performance. This is also very useful to find out like what is happening in a given snapshot in your application and what kind of performance impact you can have. Other than that, code wise, you can make use of weak map, weak set, all these things that will definitely prevent some of this memory leak for you. By the way, I'm not getting into this Chrome developer tool memory and the performance tab because that demands different video. Let me know if you are interested in learning those things very deep. As I told before, that might be again 10 days of Chrome developer tools coming up next on TapaScript. If you're willing to learn, subscribe, support TapaScript. If you are a subscriber already, it will come very soon. All right, we have come this far. I hope you're enjoying this video. Now let's talk about some of the DOM performance related things. And again, here I'm not going to show you any code because we had a module for DOM and there we had lengthy discussion about how to do DOM manipulations and everything. But let me call out few pointers. This might be recap. And if you have not gone through the DOM modules, I would definitely suggest that you go through. If you're interested in understanding DOM manipulation, performance optimizations, all these techniques, there is a module for that. But here is a recap. If you want to minimize or optimize the performance kind of problem while DOM manipulation, these are the things you need to do. Minimize the DOM access itself, because if you can't access, you don't have the performance headache. So what needs to be accessed versus what should not be accessed is your call programmatically that you have to take. Then batch the DOM updates using fragments. We have learned about fragments in terms of DOM manipulation. Please use of fragments because that's the way, the possible lightweight way to do the DOM changes and the manipulation than doing it directly. Avoid the layout thrashing, the heavy layout shifting and all this thing. We have learned about debounce and throttle, isn't it? Same thing can be applied for your high frequency events that is going to manipulate the DOM. You can apply debounce, you can apply throttle, all this thing. Use class list instead of class name overrides. We have learned that in the DOM modules as well and how it impacts your performance. Use virtual DOM. Again, folks from the React background, you know that what is virtual DOM: in memory replication through the object of your DOM, and you do all the calculation in the virtual DOM in memory, and then you apply the differences of that into the actual DOM, right? So use virtual DOM. React View already uses it, and avoid unnecessary loops and the iterations. Yeah. So this is what I would say that you should keep in mind whenever DOM comes into picture and the performance is a concern for you. Okay, so we talked about optimization like a pro, but this is something people don't talk about: over optimization. You also need to know that it is your responsibility as a developer not to over optimize for performance, because over optimization on performance will bring the performance issue, will downgrade the performance of your application. Let's talk about over optimization for some time and then we will end this session. I know it's a lengthy session, but at the same time, very, very useful. I am teaching you things from my experience. So I believe that it is going to make some impact in your development journey, make you more professional in terms of doing code. So what is over optimization? Over optimization is a scenario or is a situation when you spend time and complexity to improve something that doesn't need any optimization or has no visible performance problem at all. But you try so hard to optimize it further, further, further. For example, you write a code like this. You want to memorize a very heavy computation. This is from React, where we have a hook called use memo. The use memo hook in React actually applies the memoization things, the technique that we have learned. For the same input, if the output is already generated, cache it and return from cache. Otherwise, compute it and put it in the cache. That's the technique. But the question that you need to ask, the output that you're going to cache, that operation is really a heavy operation or not? Because there is an extra step of putting inside the cache. Why would you put something in the cache and again read something from the cache if the computation itself is so fast that it takes a fraction of a millisecond? Makes sense, right? So you won't do over optimization for the cases where it is not required. You don't want memoization when your functional computation is not itself is heavy, right? But if it is heavy, if you consider it is heavy, please do it. Similar thing I would say for the debouncing and the throttling as well, right? Why would you unnecessarily apply debouncing principle in a place where it is not required? When you're doing a client side searching within a list of 100 strings, You don't need that debouncing at all. Everything is in the client side, just 100 strings. You don't need it. But when you have to make an API call, or after searching, you have to do some kind of dumb manipulation to make the background color, giving a border of it, you have to do a lot of computation. You will think about it. So it's always things are use case basis, right? How can you identify over optimization? When can you think that are you going for over optimization or not? This is what I have learned over the period of time. You should ask yourself, is there really a performance problem or not? If you sense that there is a performance problem, test it out. The rudimentary basic way of testing it out using the console.log, console.time, date.now, performance.now, take a time snapshot comparing the time, what is it taking. If you want to go for an advanced testing, use Chrome Data Tools, memory, performance, all this tab, and try to figure out with the snapshot like what is going on. If you figure out there is a performance problem, then only think about the measures. Then next question you ask, if I apply a performance technique like debouncing, throttling, memoizations, whatever it is it going to make any real impact on the customer at runtime on their user experience? If no, don't do it. Okay. So these are the things that you have to keep in mind. Don't over optimize your code. Measure first, test first, and then optimize. This is the golden rule of performance optimization. Measure first, optimize later. That's what I will end this video with. Optimization should be deliberate, it should be measured, it should be value driven. If your app is already faster and your code is clean, you have already won. You don't need any kind of performance optimizations at all. So, my friends, I'm very happy to complete the day 36, which is the first video of module 6, our last module of 40 days of JavaScript. In the next video, I'll make sure that it is as informative as this particular session was. If you found it useful and if you're still here till the end of this video, that means you have that passion and you have that urge to learn something that you won't get to know very easily. It needs experience to teach you things like this. If you feel that it was useful to you, please like this video. Please post a like on this video. Please post a comment. Let me know what you think. I feel really happy whenever the students, whenever the viewers come back and say that it was useful. It actually makes my day. And please don't forget to share about 40 days of JavaScript. People are still unaware of 40 days of JavaScript. You, my supporters, my subscribers can do this for me. Please talk about it. Let more developers come to know about it and get benefit out of it. Stay well, stay healthy. We'll be coming back with day 37 and we'll make sure that you learn something which is more core to JavaScript. Take care.